our resistor and our capacitor, and it shows a electrolytic, if you notice. Okay, and they do a little bit of calculations here. We'll do one here in a minute. But if you look on the next page, you will see a graph, and it's like the one I gave you. Okay, and notice that the time periods go from 1 to 5, and then it's charged, and then from 0 to 5, I should say, and then 0 to 5 for discharge. Notice the 63.2%, that's where most of them are going to cut off because they're not going to wait around for 5 time periods. That's not always true, but for the most part, that's what you're going to see in the field, okay? Somewhere in that area. And we're going to actually put a lab together and do that today, okay? But before we would do that, I want to go to chapter 15, and I want to just look at filters for a minute. So we're going to experience filters also. What we've looked at so far is we've looked at DC circuits. Now, I don't want you to get confused about that, because what you're going to say is, well, yeah, it's a DC circuit, but it's actually in the 555. It's kind of AC because it's pulsing, but it's kind of DC because it's charging up and discharging. You got to visualize it. You got to say, okay, it's a DC circuit, charges a capacitor and discharges it so that I can operate something else, or I can filter something. When we talk about AC circuits, then we're talking about your motor circuits, but we're not going to talk about motor circuits. We're going to talk about filters for AC. Remember when I talked about the transmitter and I said every transmitter, the output has, maybe I didn't talk, I meant to. The output on a transmitter has a lot of harmonics and a lot of garbage if you're using like a ham transmitter, okay? But remember when I talked about the resonant circuit and how it filtered out everything but just the one frequency? Well, that would be on the radio side, but if I'm going to transmit, I want to get rid of all those frequencies that are harmonics and everything. I won't put those out on the air. That's against the law anyway. So I have a little filter in there, and it filters out that one frequency. It's AC. It might be, let's say it's 10 megahertz, that it's, the radio's 10 megahertz. That little radio I got laying on the desk back there that I use for fire, it's 160, 170 megahertz, okay? I just want that frequency to come out of that radio to the antenna. I don't want all those other frequencies. So I use a capacitor, resistor, and inductor together to get that. But the capacitor and the resistor are the one side of that, and what it does is it takes every pulse that comes out, AC pulse that comes out, and it filters it for any other garbage that's upper or lower or whatever. It filters it out to ground and just allows that one frequency through. So it's AC, but it's not like your motor circuits where you're trying to get your current and your voltage together. What you're trying to do. In this case, we're not caring about getting your current and your voltage together. What we're caring about is anything that doesn't exist at 170 megahertz. We want it to go to ground. So we use the inductor, capacitor, and resistor to do that, okay? So we're using all the frequencies other than motor frequencies, okay? Does that kind of make sense now? That's what we're going to build, is those circuits. So it's an AC circuit. It really is. But it's a high frequency, low frequency. It might be audio or whatever. It's an AC circuit. We're using it as a filter. In the DC circuit, like a power supply, we really are. We're getting rid of some garbage, but it's more DC. And when we get to this, like the 555, it's totally digital when it comes out. It's a 0 or 5 volts, totally DC. But we're getting it by allowing it to charge up and discharge, allowing it to charge up and discharge, okay? So we're using that capacitor resistor network to do that.